Welcome to Hartman Math. This is lesson 5.8, solving logarithmic equations. We've got example number 1 here. We're supposed to solve log base unknown x of 49 equals 2. And truly, our unknown could really be any one of the pieces here to get started. But right now, it's our base. So right now, maybe we know it, but easy to rewrite this out of log form and into exponential form. So rewrite into exponential form means move the base. Log disappears. Here's our base. It's going to move to the other side. So we would say 49 equals, x is the base, bumps up the 2 to be the exponent, and then we're going to solve that. So we would say, that looks like a square root method problem. So we're going to square root both sides. Don't forget plus or minus as we solve. So x equals plus or minus the square root of 49. So we get positive 7, negative 7. Here's the thing. X was a base. Bases have to be positive. It cannot be 1. So it can't be negative 7. So we're going to throw that away. So really important, any time that we have a log equation, you must check your answers because there's limitations on what the base can be and the argument. Base has to be positive and not 1. Argument has to be positive. Can't be 0, can't be negative. Cannot take the log of a negative number. So must check. So the negative, we can throw that one out in this case. X could equal 7. And that is our solution. Example number 2. This time it's the argument that's our unknown. That's all right. Yeah, I don't think we're going to know this one off the top of our head. So let's go ahead and rewrite out of log form into exponential form. We're going to move the base 27 to the power of 2/3. This takes us back to a previous unit where we had fractional or rational exponents. We want to rewrite that as a root. Index, power, x is the cube root of 27. Raised to the second power. Cube root of 27 is 3. So we're talking about 3 to the second power, and that is 9. We got to check to see if that's actually doable. Log base 27 of 9. Yeah, we can take the log of 9 because that's a positive number. That's the main thing that we are checking for. So we're okay there. We can box that answer. That one's okay. All right, it's now your turn, so go ahead and pause the video here until you're ready. We're going to rewrite it. Move the base is 5, so x equals 5 to the power of negative 1, and we got to figure out what that is. Negative exponents mean level change. Send it to the bottom, 1 over 5 to the first, so that just means x equals 1 over 5, 1/5. And that is a positive number, so we're okay there. We can take the log base 5 of that positive number, box your answer, it's okay. Example number 3. Ooh, this one looks a little bit more complicated. Let's give it a look. Log base 3 of a larger expression is equal to 2. Same process. Rewrite this out of log form into exponential form. Move the base of 3. It's going to bump up the 2 to be the exponent, so we'll have this equals 3 to the second power. 3 to the second power is 9. So really we're thinking this is just 9. We do have a quadratic equation, so probably a good idea to get it equal to 0. Since this is 9, let's go minus 9 both sides. And this turns out to be one of the, if we're going to use factoring as our approach, I think we should, one of the more challenging factoring problems that's kind of a basic factoring problem. and it's due to the sign issue. So really focus on the sign here, because it's very common that people say, parentheses, x minus 2 and x minus 3. Because that makes this, it doesn't make the negative 6. You cannot have two numbers next to the x that are the same sign. They won't make negative 6. We need a positive and we need a negative. So that's why this one would have to be x plus 1 and x minus 6. That's the negative 6. Negative 6x plus 1x is negative 5x. All right, we're going to split them apart. Use the zero product property. X plus 1 equals 0. X minus 6 equals 0. We get possible solutions of x equals negative 1 and x equals 6. We're going to be very suspicious, especially of the negative. We're going to have to plug it back in to see if it's okay. So right here it says, all right, we're going to have to try negative 1. So negative 1 squared is 1. Negative 5 times negative 1 is 5. So 1 plus 5 plus 3 is 9. Well, yeah, we can take log base 3 of 9. In fact, we know that log base 3 of 9 is 2, because 3 to the second power is 9. So that one's okay. What about the 6? 36 minus 30 plus 3, that's also 9. So that one's also okay. They're both solutions. All right, it's your turn. Go ahead and pause here, work through this solve problem. All right, let's go ahead and rewrite, keep that, get rid of log, move the 5. 5 is the base to the power of 2. So x squared equals 25. So square root both sides, plus or minus, x equals plus or minus 5. Ooh, I'm a little scared of the negative. But anyway, positive 5. Well, 5 squared is 25. Log base 5, it's a positive number, so we're okay there. 5 to what power is 25? That one's 2. If we try negative 5, first thing it says to do is square it. You get 25. So log base 5 of 25, that's doable because you can take the log of a positive 25. So both, again, are solutions. So that brings us to the one-to-one property for logarithms, which simply states if both sides are log same base of an argument, and that's all we see, log equals log, then the arguments have to be equal. X would have to equal y. What does that look like? Well, here's example number 4. Log base 7 of something equals log base 7 of something. So it definitely fits this idea of the one-to-one property where we can, in a sense, ignore. We're not canceling out. We're going to ignore and say, well, that means that argument has to equal argument. And that's what our equation is going to be based on. X minus 2 is equal to 2x plus 8. All right, so we're going to solve. It's linear. No need to get it equal to 0. I am thinking that we should get rid of this x, so we'll subtract 1x on both sides. And therefore, we've kind of committed to getting the x's on the right. Let's get rid of the plus 8. Let's go minus 8 both sides. And then let's check. So x is negative 10. Negative 10 minus 2 is negative 12. Log base 7, no, you cannot take the log of a negative number. So that's not going to work. Even though if we plug it in, it sounds right. It says log base 7 of negative 12 equals log base 7 of negative 12. There's no such thing as log base 7 of negative 12. It doesn't make any sense. So because we cannot take the log of a negative number when we plug it in, okay, that means we got to throw this out. So throw that out. That was our only thing, so it's got to be no solution. And that's our answer. All right, one last your turn to work on. Go ahead and pause here and work through it. All right, let's see how you did. First question It says log, what's the base? And log, what's the base of the logarithm? Remember, the common logarithm says if you don't see the base, it's base 10. Okay? I don't think that really matters to the problem because the bases are the same, so we can say argument equals argument. It's quadratic, so let's get one side equal to 0. Let's try factor. If that doesn't work, maybe we go quadratic formula. But I think it factors. And split them up. Apparently I've already ruined it, but I think they both check out, even the negative, because we would substitute in negative 5 squared is positive 25. Plus negative 5 is 20. So log 20 equals log 20. We can take the log of 20. 20 is a positive number. When we substitute in 4, we also get log of 20. So both are okay. That's it for today. See you next time.